Assalamu alaikum students. I hope you all are doing well. So, we started the topic of types of matrices and we have done 8 types of matrices, and now we are going to do 4 more types of matrices. The 4 types to be done today are scalar matrix, unit matrix or identity matrix, equal matrices, and triangular matrix. So let's see them one by one. First one is scalar matrix. Its definition is scalar matrix: if all the elements in the diagonal of a diagonal matrix are equal, it is called a scalar matrix. Thus, a square matrix. Let me give you an example. As we know, what are the diagonal matrices? Diagonal matrices are those matrices whose diagonal elements are non-zero, and other than diagonal elements, all the elements of the matrices are 0. Okay, so this is the diagonal matrix, and the diagonal matrix in which all the diagonal elements are equal, then it will be scalar matrix. So the scalar matrix example is this one. Let's say it is 2 0 0 2. A is equal to this one. Okay, so in this matrix the diagonal elements are equal to what? Diagonal elements are both are 2, and non-diagonal elements are 0. So the condition is that diagonal elements should be same or equal, then it will form scalar matrix. Okay, so I think so you have got an idea of what is scalar matrix. Now let's move towards the second definition, second type, unit matrix or identity matrix. Okay, unit matrix or identity matrix: if all the elements of a principal diagonal in a diagonal matrix are 1, it is called a unit matrix. A unit matrix of order n is denoted by in. Okay, so it is same as scalar matrix, but the other condition is that in unit matrix or identity matrix, the elements of the diagonal will be same or equal in the scalar matrix. But for identity matrix, what? The diagonal elements should always be 1. Okay, it is a matrix of 2 by 2 which has first element and the last element 1 1, means both the diagonal elements are equal and 1. So it makes unit matrix or identity matrix. The other example for identity matrix will be this one: 1 0 0 0 1 0 0 0 1. So all the diagonal matrix the diagonal elements are 1 1 1. They are equal, so it can be called as scalar matrix. But for more specification, what we say, because they are equal and elements are 1, so it is unit matrix or identity matrix. Okay, so the next type is equal matrices. As it is apparent from the name itself that equal matrices will be those matrices which has equal number of columns and equal number of rows, and their elements are also the same or equal. Okay, let's read the definition. Equal matrices are those matrices which are equal in terms of their elements. Okay, whose elements are equal. Two matrices which have same elements, then they will be called equal matrices. The conditions for matrix equality are discussed below. So the conditions are three conditions here. Three conditions are here for equality of matrices. The first condition says, okay, let's read it first. Equality of matrices conditions: two matrices A and B are said to be equal if they are of the same order and their corresponding elements are equal. Means of the same order means m into n is same for both the matrices A and B in our case, because we are taking A and B as equal matrices. Okay, and then their corresponding elements are equal. If two elements are equal, if two matrices A is equal to Aij m into n and B is equal to Bij r into s, okay, are equal, then what condition should be fulfilled for equal matrices? Number 1, m is equal to r. means number of rows of first matrix A and number of rows of second matrix B. The number of rows in A is equal to the number of rows in B. N is equal to S means the number of columns in A, that is N, that is denoted by N, and here N, okay. And the number of columns S should be equal. Here R into S, and for A M into N. M will be equal to R and N will be equal to S. Number of rows of A will be equal to number of rows of B, and number of columns of A will be equal to number of columns of B. The third condition says that it is for the first two conditions, M and N, A and B, are for order. Okay, that order should be equal of the two matrices or equal matrices. And the last condition C is for the elements. It says Aij is equal to Bij, means the for I is equal to 1, 2 and so on to M, and J is equal to 1, 2 so on to N. The corresponding elements are equal. This condition says that all the elements of the matrix A, which is denoted by Aij, and all the elements of the matrix B, which are denoted by Bij, they all should be equal or same. Okay, now let me give you some examples. One example only. We have matrix 10, 20, 30, 40. This is matrix A, okay, and the matrix B is 10, 20, 30, 40. They are the equal matrices. They are equal matrices, okay, equal, because all these conditions are fulfilled. Their order is same because M into N. A's order is what? 2 into 2. 2 rows, 2 columns, and B's order is what? 2 into 2. 2 rows, 2 columns. So their order is same, and their elements, corresponding elements, are also same. This is 10, this is 10. First element is 10. This is 10, 10 or 20, 30, 40. So they are the same elements. Same elements of two matrices. So it is equal matrix. Okay. Let me give you one example for clarification. Like if we have two matrices A and 10, 20, 30 and 48 are its elements. On the other hand, we have same elements but in different order. Like 40 is here, 20 is here, 10 is here, and 30 is here. They have the same order, 2 into 2, 2 into 2. Okay, but their corresponding elements are not equal. See, the corresponding elements are not equal. At first position, first row, first column, here is 10, but here is 40. So from here, the first element, we know that they are not equal. Not equal. Equal. Okay, because for equal matrices, the two conditions are that their order should also be same. Order of the matrices should also be the same, and the corresponding elements should also be the same at the same position. Okay. Okay. So the last type is triangular matrix. What triangular matrix says is, it is also related to a diagonal or square matrix. Okay, diagonal matrix. Let's read the definition. A square matrix is said to be triangular matrix if the elements above or below the principal diagonal are 0, and there are of two types. Upper triangular matrix. A square matrix Aij is called an upper triangular matrix if Aij is equal to 0 when I is greater than j. Lower triangular matrix. A square matrix is called a lower triangular matrix if Aij is equal to 0 when I greater than j. It is somehow complex. I will explain it through an example and you will get it. Okay, no issue at all. Okay, I'll explain it here so that you can relate it to the definition. Okay, okay. So the definition says a square matrix is said to be a triangular matrix if the elements above or below the principal diagonal are 0. If we have a matrix like this is principal diagonal, and the elements above or below, means one condition should be fulfilled at a time. The elements above the diagonal or elements below the diagonal should be 0, then it will be called triangular matrix. Okay. Okay, so look at here. 1, 2, 3, and it's these elements above the principal diagonal, above, this is called principal diagonal, are 0 0 0, and below is 4, 3 and 2. Okay, see, this is first example of triangular matrix, and let me give you another example. This is the lower triangular matrix, and this is the upper triangular matrix, because see, it is making a triangle below lower triangular matrix, and this is making a triangle above, so it is upper triangular matrix. But in terms of math, how we will recognize which will be lower triangular and upper triangular is that a square matrix Aij is called an upper triangular matrix if Aij is equal to 0 when I greater than j. When the number of row is greater than number of column and the element is 0 0 0, then that will be called upper triangular matrix. See, in this case, row number is greater than column number, because second row first column, here third row first column, and this one is third row second column. So the number of row is greater than number of column, and the elements, these three elements are 0 0 0, so it is upper triangular matrix. And for lower triangular matrix, the case is opposite to the upper triangular matrix. When the number of column is greater than the number of row, then the elements will be 0, and other than those three elements, all the elements will be non-zero and will make a triangle. So they were the two types of triangular matrix, lower triangular matrix and upper triangular matrix. I hope you have got an idea of what I have told you today, and if you have any confusion, you can ask me in the comment section. Thank you so much.